Hello, have a good day, IETV viewers. Now I have come with the lesson 3. This is Introduction to Analysis of Structures and Procedures. According to BS 8110 Part 1 1985 via IETV International Education TV. Let's quickly move to introduction. So introduction is aim of structural analysis, design load combination, choice of critical loading arrangement, analysis of structures, design procedures. This lecture may be the last lecture that you have to watch before starting our design works. Then after this lecture I am going to teach you how structural designing are done. So the after this lecture I will teach you from the basics to the deep designing. So that means simple beam designing to then high-rise building designing. From after this lesson I'm going to teach you, and also before I want to teach you how bending moment and shear force diagrams are drawn for different cases. So those things will be taught to you in next lecture. So let's move to this content. Aim of structural analysis. This has been clearly indicated in clause 25 of BS 8110 Part 1 1985. You can have that book, otherwise you will not be able to clearly identify what have been included in that book. So if you want to have a good designer with this lecture series, you have to have that book. You have to keep and study that book, otherwise you won't be able to catch this lecture series without that book. You can easily download that book from internet, that is BS 8110 Part 1 1985. Just type that one and you can download it. So to obtain set of internal forces and moments. So structural analysis means that if you think that you have to design a building, so you know that you can easily find external forces, that means support reactions, but it is very important to have internal forces than external forces to design a section. If let's think that you have to design a beam, so you have to you have to calculate what are the internal forces, not the external forces but internal forces, such as shear forces, bending moments, axial forces. According to the value of that forces, you have to design the amount of section, that amount of reinforcement that we should provide, and also section dimensions. So these are the main structural analysis aims. So to obtain set of internal forces and moments throughout the structure with the design loads and specified load combination. For this is main aim of structural analysis. So I will tell you one by one within this lecture series how we start structural analysis. Concrete structure is a combination of beams. You know that any structure, concrete structure, that means any building consists of beams, columns, slabs, and also footings, piles, and so many things like that. So to design those sections, you have to have internal forces, not the external forces, but we use those external forces to calculate the internal forces, which are shear forces, bending moments, torsional and axial forces. Those internal forces are the internal forces govern design processes. The internal forces develops due to external forces, that is true, but we use internal forces to design structure. Therefore we have to do structural analysis properly throughout the structure to have critical loadings on each and every sections. So so let's move to next one. To justify a design, so listen, there's a design building. You have to check whether it is adequate to the external loads. If you are going to check, you have to do structural analysis. To justify the design that you have given, you have to have structural analysis, that whether the provided reinforcement area is adequate or not, and also the section dimensions are adequate or not. You have to decide after analyzing of the structure. So let's move to next one. Justifying a design. Let's talk about small things about justifying a design. Analysis carried to justify design can be broken into two stages: the analysis of structure or part of structure. You can analyze total structure and also a part of structure to justify a design, and also you can analyze even a section. So you can calculate a load on that section, external load on that section according to the bending moment and shear force diagrams. You can have external, internal, maximum bending moment and shear forces, even axial forces. Then according to that you can check whether the provided section is adequate or not. Another important thing that code has been mentioned, that when analyzing a structure, properties of materials of material maybe those associated with the characteristic strength. That means we have to, when we analyzing a structure, we use characteristic we use material properties as Young modulus. All the things are associated with characteristic strength of that material. But when we analyzing a section, when we analyze a cross section, when a section, we use the material properties which are associated with the limit state which are considered. So those things are discussed. I will be discussing when we are doing exercises. So design load combination, you know that even in my first lecture I told you we are mainly using when load combinations. You know that dead load means weight of structure, imposed load weight of structure, weight of partitions, maybe those are permanent loads. Dead load means that you can take weight of the structure, that means weight of the section, that means let's consider the beam, the weight of concrete, weight of steel, and also weight of finishes. If there are some partitions on there, those are permanent partitions, those are dead loads. And also there may be some permanent structure or some permanent concrete point load column on that beam, that also we can consider a dead load. And also imposed load means loads of people's temporary partitions, and also all the movable loads. That means loads of that movable partitions, likewise all the things. And wheel load is the lateral loads, the others are vertical loads, those wheel loads are lateral loads. When we designing, we have to calculate separately dead and imposed loads. You can calculate, I will teach you in next sessions how to calculate those loads. Just you have to keep remember this theory. So dead loads, we can calculate dead loads and wind loads, imposed loads separately. If there are wind loads, you can we consider, normally we consider sometimes in buildings, wind loads is higher as buildings up after 3 or 4 stories. If they are we have to consider lateral loads, we have to have even a small buildings, we have to consider those loads even in a small building. So then you can calculate wind load, with the wind load calculation methods are given in CP3 chapter 5. In CP3 chapter 5 I will teach you those things in later. So it has not been given in this BS code, but there is another code to calculate wind load. And also you can get imposed loads. There are imposed loads, that means categorized imposed load on BX 6399 part 1. Also you can there is another code there, so you can use that code to calculate imposed load. They have given the imposed load for even in a house residence categorized as categorized loads. So they have given imposed load for separately for classrooms, housings, restaurants, hospitals. Those have given, they also have been given that another code. So I will teach you how to get those things as well when we are designing. So when we are calculating ultimate loads, these are ultimate loads. When we are designing, we have to design, you know, I told you that when we are designing a building, we have to design it to ultimate loads, that means ultimate limit state, and we check whether it is okay for serviceability limit state. That means serviceability limit state means the factors we use are 1 for each when we are adding those dead and imposed loads. I have discussed in my first lecture. So the calculated dead and imposed loads for the ultimate limit state, we multiplied dead load by 1.4 and add it to imposed load, which have been multiplied by 1.6 in likewise. And also when we engage with both wind imposed and dead loads, the multiplied factor is 1.2. so they may be slightly different, those loads. All the cases we have to consider when we are designing. For you can learn in future lectures. Let's move to choice of critical loading arrangements. So when we let's consider this beam. Let's consider this is a beam, these are columns. When we calculate ultimate loads, that means dead load factored dead load plus factored imposed load. Why we have factored? We have factored, this is due to, this factors is due to addition, that means for safety factors. These are for sudden increase of loads will take care of these loads. That is why we use these factors. We have designed ultimate limit state with higher loads than actual loads. That's why we have multiplied this load. In this beam, you think that this load, you calculated this load continued uniformly. This is one case. In this beam, you can consider another alternate spans with maximum loads and minimum loads. This is another load arrangements. That means you think that this is a beam. Sometimes this beam may be fully loaded. In sometimes it will be partially loaded like that. In that means alternate spans. This is spans between these columns. Alternate spans. This span is fully loaded and this is not loaded, and this span is fully loaded, because we have to consider all these load combinations, because you think that because the whole beam is not fully loaded at a time. sometimes it may be partial loaded like this. So those in these two occasions there are different types of movements and in different values of internal forces. Those things are have to be calculated. Sometimes in here sometimes this bending moments is in that mid part maybe slightly higher. In this case sometimes bending moment is lesser. Sometimes in here bending moments may be higher than this one. So when we are calculating those things according to fixity, those things may be vary. So therefore all the load combinations we have to consider. If otherwise you can't get the actual behavior of the beam. So if you are going to design a beam, you have to consider this load combination and also this these two load combinations in alternate spans. Then according to bending moment diagrams which have been drawn for those which are drawn for these two cases, you can calculate what is the maximum bending moment at mid span, what is the maximum bending moment at this support. According to that you have to design. You have please keep remember, you can learn easily if you are watching this lecture series continuously. Then analysis of structure. Analysis of structure means you think that there is a building, or sometimes typical buildings there are typical frames like this. So therefore simplification, we have to simplify this building. Let's think that this is the building. Let's think that this is 2-story building, and you can consider this frame to perpendicular to this direction. So let's think that this is the frame. You can analyze this frame and calculate those bending moments. Likewise you can simplify those structure to subframes, and also you can consider this bottom frames as well. Only this bottom frame. So when we are considering this bottom frame, you have to put those additional loads due to these columns externally. Then only you can analyze this section. Otherwise you can't do that one. If you are going to analyze this upper part, you can do it. If you want to analyze this section, this bottom frame, you can do it. Then if you are going to analyze this frame, you have to have this column load as well. For consider this column load as well. So you can learn well. And also if you want to analyze this beam only, you can consider this beam only. So all the things I will be taught you. And also LV of forces may be derived from linear, elastic or plastic analysis. In the code this analysis is can be done. It has been in the code, it has been stated that this analysis can be done by linear elastic analysis methods. That means linear elastic analysis method means that it follows Hooke law. You know that Hooke laws. That means stress strain diagram is proportional area. In the we consider in the proportional area in the stress strain diagrams. That I taught you in the my first lecture on that. And also plastic analysis, that means yield line analysis method also can be used for structural analysis. So those things so as earlier you can teach, you can learn well in my future lectures. Properties of materials as Young modulus should be the one which associate with their characteristic strength. Earlier I told you in this regard. Analysis of structure. Relative, that means continued. Relative stiffness of members may be based on the following. We have to calculate stiffness for designing of columns, and also those stiffness columns and being design of columns. Sometimes in the moment we have to we use moment distribution method to calculate bending moment diagrams. So therefore relative stiffness of members, beams, columns we have to calculate. You can learn in my future lectures that those things. So therefore in this case following things we have to follow. Concrete section, entire concrete section ignoring the reinforcement. We ignore reinforcement when we consider the cross section. Cross section, entire cross section including the reinforcement on the basis of modular ratio. The transformed section, the compression area of the concrete cross section combined with the reinforcement on the basis of modular ratio. You can learn modular ratio means ratio between the modulus of elasticity of steel and modulus of elasticity of concrete. That means ratio between modulus of elasticity of steel and modulus of elasticity of concrete. In code has given this note as well. Modular ratio in the above can be assumed as 15 in the absence of better information. In the absence of better information, you can learn well in my future lecture series. This is just to keep remember. You read this lesson, you will watch this lesson continuously, then you can understand when you designing those things, because these are the basic things. You can just read it, but sometimes you may not be able to understand these things well, but you can clearly understand when you are designing, because these things are connected with designing. So I am teaching you this lesson without a designing part. The design part will start with the new next lesson. So with that you can gradually learn those things, that what is the relative stiffness, modular ratio, and how we can calculate maximum bending moments and shear forces, subframe analysis, section analysis, then ultimate state design, limited state design, all the things. Don't be afraid, please keep watching this lecture series. The structure should be analyzed for critical loading conditions. You know that I told you that we have factored and dead and wind loads and then added. So those are the critical loading conditions. So we have to when you are designing critical loading condition, you should be conditions. Mainly using moment distribution method, I will teach you this one to calculate when bending moment diagrams, we have to we want to get the maximum shear forces and bending moments. So therefore that moment distribution method is the method which is mainly used for subframe analysis, and also computer analysis can also be used to get that maximum bending moments and shear forces. That means SAP, ETAP, Procon softwares can be used. I will teach you SAP lessons will be you can watch on the SAP lessons in my future another lecture series, computer aided design lecture series. You can learn that as well, and also ETAP and Procon. Bending moment diagrams, when we take that bending moment and shear force diagrams for each load combinations, that means that you consider that this is a fully loaded section, that you, in that case earlier that I showed you that this beam, in this case we can draw a bending moment diagram in the same beam, and so for this load combination as well you can draw another bending moment diagram like in the same beam section. So in here we consider this frame, let's think that this the one bending moment diagram is, we have considered dead and full imposed loads, dead load plus full imposed load. This is the upper one is that bending moment diagram in here, and also here this one, and also in here bending, when we are designing dead plus, we have decided only consider dead and wind load. This is that bending moment diagram. Then there is a 2, and another loads get dead and dead plus imposed load. In here only BC, other section is has not considered that, only considered dead load. So therefore these are 3 bending moment diagrams for each load combinations. We have considered 3 load combinations: dead load plus full imposed load, dead load plus wind load, dead load plus imposed load in here. So by considering this, we call this is bending moment envelope for this total diagram. So according to the bending moment envelope, you can have this maximum bending moment and shear forces for your design works. So design consists of the following. So you can understand easily: planning carried out by the architect to determine the arrangement and layout of the building as per the client requirement. You know that planning and initial designing is not designing, initial planning is done by architect. According to his requirement, we have to design the building. So first thing is to identify the architect requirement, which is in accordance with the client informations. And also then after that idealization, we have to identify the structure, and also we have to do preliminary calculation of loads, and we have to sometimes we in that layout drawings, we have to change some sections, the locations of columns, and sometimes we may have to change according to load distribution. Column, you have to have additional columns, and also you have to change that layout architectural drawings by discussing with the architecture. Then after that, you have to idealize the subframes that we can analyze the section. Then you have to estimate loads. That means according to you can calculate dead loads according to that density of concrete, density of steel. That means reinforced density of reinforced concrete is 24 kN per square cubic meter. So likewise you can calculate section weight, and also you can calculate the imposed loads from that code that I have told you, base 6399 code, and also wind loads you can calculate CP3 chapter 5 code. Then after that you have to have factored that load, and also you can calculate separate dead and imposed load, dead plus imposed load, dead plus imposed load plus wind loads, and factor dead load plus imposed load. That means 1.4 dead load plus 1.6 imposed load, and factor dead load imposed load wind load. That means 1.2 dead load plus 1.2 imposed load plus 1.2 wind load, and also likewise you have to factor those loads. Then after that you have to assign those loads for beams, as I told you earlier. Fully loaded, guys, partially they separate, alternate spans loaded those loads. So therefore according to that one, you have to analyze those from frames by using linear elastic methods, and also you can use that moment distribution method to calculate end moments. So then according to that you can have bending moment diagrams. So then you can have bending moment envelopes. From bending moment envelopes you can have maximum bending moment and shear forces for the design works. Then according to those bending moment envelopes, you can design the sections in accordance with the instruction given in BS 8110 part 1 1985. Then you can I have told you that earlier that this design is iterative process, so you can check with that whether this section is adequate enough for that means cost effectiveness of the section. If this section is very large, you can have that means you can calculate that design procedure again, recalculate, and with that means lower dimension, that means smaller dimension than previous one. So then you can have a small section which is adequate for those loads. So likewise you have done that design repeatedly, and you can choose most effective section for the the critical load combination. That is the design process. Then after that you have to produce layout drawings, design drawings, bar schedules. You can draw by using AutoCAD. And this is the end of this lesson. Please subscribe me if you learn something. Thank you.